GeopByte.
Let us take the another important problem. Look at this problem asking like this. A gravitational field is present in a region and a mass is shifted from A to B through different paths shown in figure. The mass is shifting from A to B. Look at the diagram. From A to B. One path is through 1, other path is 2, other path is 3. Then, if W1, W2, W3 represent the work done by the gravitational force along the respective paths, work done by work done by the work done by the particle in the what in the path 1 is W1 in the gravitational field, path 2 is W2, path 3 is W3 in the gravitational field. Then what is the relation between the W1, W2, W3? Dear friends, remember the gravitational force is the conservative force. Whatever the work which is developed due to conservative force does not depend on the path following. That means in the gravitational field, since the gravitational force is coming under conservative force, work is independent on the path following. It means whether the particle is moving from A to B via 1 or 2 or 3, work remains same. Therefore, I can say that W1 equal to W2 equal to W3. Therefore, look at the option A. Option A is absolutely correct. This is very, very important problem. This kind of problem can be repeated. Okay. Similarly, look at the another important problem asking like this. The energy that will be ideally radiated by a 100 watts transmitter in 1 hour is, here power given, power P equal to 100 kilowatts. It is equal to 100 into 10 power 3 watts equal to 1 into 10 power 5 watts. Okay. Next, look at the time period. The time T equal to 1 hour. This 1 hour equal to 3600 seconds. Then you are asked to decide what is the energy transmitted. Energy E equal to how much? Okay. As you know, power P equal to, as you know, power P equal to, power P equal to energy per second. Energy per second. Therefore, energy equal to power multiplied by time which is in seconds. Time which is in seconds. Look at the power. 1 into 10 power 5. Time is 3600. Simplify this value for getting 36 into 10 power 7 joules. That is the energy transmitted by the transmitter. Look at the option D. Option D is absolutely correct. Okay. Na? Yes. Similarly, let us take the another important problem asking like this. An electric lift with a maximum load of 2000 kg. The 2000 kg is the lift weight plus passenger's weight. Is moving up with a constant speed of 1.5 meter per second. Let us take the lift. This is the lift. A constant force is acting on the lift, right? Lift to maintain the constant velocity v equal to 1.5 meter per second, right? This lift weight and passenger's weight. Passengers are there on the lift. So lift weight and passenger's weight. In fact, mass given. Then weight equal to product of mass and G. So weight equal to mass is 2000. Look at the G value given. G value 10 equal to 20,000 newtons. Okay. The frictional force opposing the motion is 3000 newtons. You know, frictional force always acting opposite to direction of motion. This is the direction of motion. That is the direction of motion. Therefore, frictional force is also acting along the weight direction. That frictional force F is given as 3000 newtons. The minimum power developed by the motor to lift the to lift in watt. That means what is the minimum power required for lifting the lift by means of a motor. Means indirectly he is asking motor power. First, let us decide the total force. Total force against which the lift is moving equal to weight plus frictional force. That is 20,000 plus 3,000 is equal to 23,000 newtons. Then what is the power? As you know, power P equal to total force multiplied by the velocity. Total force is 23,000 multiplied velocity 1.5 is equal to 34,500 Newton meter per second. Because force is in Newton, velocity is in meter per second, Newton meter per second or watt. Look at the options. Look at the options. 34,500 option B. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. A particle is released from height s from the surface of the earth. A particle is initially available at a height of s from the surface of the earth and it is releasing from that height means initial velocity of the particle is 0. At certain height, its kinetic energy is 3 times the potential energy. By the time the particle is traveling down towards the surface of the earth, at a particular point, its kinetic energy is 3 times the potential energy. The height from the surface of the earth and the speed of the particle at that instant are respectively. What is the instantaneous height from the surface of the earth where the kinetic energy is 3 times the potential energy and what is the speed of the particle at that instant? Okay, for that, let us take the earth. Look at the earth. First, let me mark the surface of the earth. Let me mark the surface of the earth. This is the surface of the earth. Okay, this is the surface of the earth. Surface of earth. Let me mark the initial position of the particle. This may be the initial position of the particle. Let that is A. At that A, initial velocity u equal to 0 because it is dropping down. And this height is given. This height is given as s. Now that particle is moving towards surface of the earth at a particular instant. Let that is particular instant point B, right? At that point B, the kinetic energy at B, kinetic energy is three times the potential energy. That condition is given. Then what is this instantaneous height h and what is the velocity at B? That's the question. For that, you know, work energy theorem says that total energy remains constant. That means total energy at A must be equal to total energy at B. Here total energy means kinetic energy plus potential energy at A must be equal to kinetic energy plus potential energy at B. But the particle is initially at rest means kinetic energy at A equal to 0. Kinetic energy at A equal to 0. Then I can say that the potential energy at A must be equal to kinetic energy at B plus potential energy at B. Okay. It is given that kinetic energy at B is 3 times the potential energy. Let us take another otherwise. Potential energy at A equal to kinetic energy at B is 3 times the potential energy at B plus potential energy at B. It is equal to 4 times the potential energy at V. Okay, let me take another slide. Kinetic energy at A equal to 4 times the potential energy at B. Kinetic energy at potential energy at A. Take a minute. You should be very careful. Potential energy at A must be equal to 4 times the potential energy at B. Potential energy at A is available at a height of S. Therefore, it is mg. S must be equal to 4 times the mg into h. That is marked as h. Okay. Now, this mg part is cancelled. Then S equal to 4 times the h. Therefore, height of that particular instant equal to S by 4. S by 4. Okay. Now, that is the height. Velocity you need to decide. As you know, the kinetic energy at B is equal to 3 times the potential energy at V. Kinetic energy at B equal to what? Half into m into Vb square equal to 3 into potential energy at B is m into G into H. Half into m into Vb square is equal to 3 times the mg into H equal to what? S by 4. H equal to S by 4. Now you can cancel m Vb square by 1 minute. 1 minute. Where it is gone? 1 minute. Okay. Vb square by 2. Vb square by 2 equal to 3g s by 4. Here it is 2 times. Finally, it is Vb square equal to 3 by 2 gs. Therefore, velocity at B equal to root over 3 by 2 gs. 3 by 2 gs. Vb equal 3 by 2 gs. H equal s by 4. H equal s by 4. 3g s by 2 na. 3g s by 2. Absolutely correct. Look at the option B. Option B is absolutely correct. Understood clearly? It is very, very important problem. I can say 5-star problem. Means this kind of problem can be repeated. Okay? Try to practice, right? 2 to 3 times this problem.
GeopByte.